got for y'all today is a look at a little program called Rock, Paper, Scissors. This is my take on the classic programming assignment slash exercise slash video that you're going to see a lot. I'm sure there's hundreds of YouTube videos showing someone's version of Rock, Paper, Scissors. Here's mine, and I'm going to break it down for you. As you can see, the code is already typed up, so I'm not going to be typing live. I'm just going to break it down. What I like to do a lot of times is before I break it down, I'm going to just run the code so you can see what it does. Then we'll talk about the actual code breakdown. So I'm going to run it here. Starts with, what is your move? Rock, paper, scissors. Type Q to quit or exit to quit. So with this one, I get a prompt and I type in rock, paper, or scissors. And then what happens is I play against the computer, and the computer will randomly choose rock, paper, or scissors on their end, and then they get compared, and the winner is displayed or chosen or dictated, however you want to say it. So I'm going to type in my move. My move will be rock. And you see here that I win, because I entered rock, and CPU's move was scissors. And so rock smashes scissors, we all know that. So it loops back around and asks me again. This program is designed to continually loop until you end. So until I press Q, quit, or type exit, we're going to keep the party going. So I'm going to enter paper this time. And I lose because the CPU's move was scissors. Scissors cuts paper, and there we go. So I'll do one more run here. I'll choose scissors this time, if I can spell it correctly. There we go. I lose again. I entered scissors, and CPU, which is computer, entered rock, or the move was rock. So rock smashes scissors like we saw up above. So that's that. And now I'm gonna do one of these commands to quit. I'll type in exit. And a little message there. Hope you had fun. See you later. Well, that's the operation of the program. So now let's look at the code for this one. Oh. Starting up at the top, we import random because random is going to be used to select the computer's move randomly. And the move is actually going to come randomly from this list right here. I have a list of moves, rock, paper, and scissors. And the computer's move is going to be randomly chosen from those, from that list. Then overall, I have a loop here, not a list. Get those confused with the L's. I have an endless while loop here where the entire game is going to be inside this loop. And of course, no loop is truly endless or infinite. I'm going to be able to break out of it at spots with the break statement. So of course, it's not going to be endless, but it's set up that way. So I go into this loop, and the first thing I do is my prompt, the prompt that you saw when I ran the program. What is your move? Rock, paper, or scissors. Type blah, blah, blah to quit. So that's really the first thing that happens in the game. And what is here is input validation, really. Well, actually, no, this is not input validation. Sorry, this is the quit mechanism. So if they enter quit, Q, or exit, print my little goodbye message, and break is going to leave this loop, and the end of the loop is the end of the program because there's nothing after that loop. And then later on here, have a couple of lines where I take the move that was entered via the input function. I take it and make it uppercase because it's going to be compared against this list, and all the items in the list are uppercase, so I want to be able to match later on. CPU move, this is a randomly generated number between 0 and 2 inclusive that is going to be used to index into this list to choose a move. For instance, if I randomly generate a 1, it's going to get paper, and paper would be the CPU's move. So it's a randomly generated integer which is going to be used to index into the moves list. And next here I have some input validation. This is the input validation, where if what was input, the user move, if that move is not in the moves list, meaning that if it's not rock, paper, or scissors, I'm going to print a message that says, hey, you got to enter rock, paper, or scissors, homie. And once that prompt or that message is put out, I do a continue, which is going to loop right back around to the beginning of this loop. And I'll ask for input again. So continue will go to the next iteration of the loop. Let me scroll down here a little bit. The rest of the code works out in a bunch of if statements. And the first if statement here is for a tie. Oops. Check this out. It says if user move equals moves index CPU move, then you do something. Well, let's take a look at this right here. Moves is the list of rock, paper, or scissors strings. CPU move is the randomly generated number. So this this code right here actually equals the CPU's move. It's going to be rock, paper, or scissors. And if that move is equal to the user's move, we got a tie. And then what it says is we have a tie. You entered whatever you entered. The computer's move was whatever the computer chose. And when you have a tie, well, you're just going to continue, go back around to the beginning of the loop. So there, the tie has been handled. Moving up next is the next series of if statements. Really, you have ifs and nested ifs, and they all follow the same format, really, where it's checking your move. If your move is a certain thing, it compares it against the CPU moves or the computer moves to see if you win or lose. For instance, if your move is rock and the computer move is paper, you lose because paper beats rock. Paper covers rock. If your move is rock and the computer's move is scissors, you win because rock smashes scissors. We know that. The awesome power of the rock. So these other if statements lay out just like this. Look at the next one. If you got paper and the computer's got rock, you win. Paper covers rock. Your move paper, computer move scissors, you lose because the scissors cut paper. This is how these if statements go. And then there's one more if statement down here. It's for scissors. And that's the end of the program. There's not a lot to it. To kind of recap here, it's of course, create the list of possible moves. Create your endless, create your infinite while loop and prompt for the move, do handle the quitting, input validation, then we check for a tie, and then we really develop logic for all the moves. You know, if you got this and they got that, here's the outcome. So it ends up being a pretty simple process. And yes, here it is. So let me see if I can get it on a single screen in case you want to screenshot it or whatever or copy it. But here we go with this. This is a little condensed, but yeah, if I take out the spaces, I think I can get it on a single screen. At least I can get all the loop on a single screen. So there's that. And then if you scroll up a little bit, you got a couple of more lines. But yeah, this one's pretty straightforward. Rock, paper, scissors, my version. I want to see how you guys do it. Maybe you guys can take this one and spark some ideas for your own way. There's much better ways to do this. This is kind of a simple explanation way to do it, but you can condense, you can be more efficient. So try it out and let me know. But that's my time here, and catch y'all on the flip side. I'm out.